In past videos, we've evaluated indefinite integrals, and so now we'll be looking at definite integrals. So what is a definite integral and how does it differ from an indefinite integral? And basically, a definite integral is just a standard integral that's evaluated at two separate boundary conditions. So you can see here in our formula, our boundary conditions are a to b, and basically how we solve this is by integrating the function and then evaluating it from our boundary conditions. So we'll have the solution to our integral f, or large capital F of x, and we have our boundary conditions b and a. And so basically all we do is we plug in our boundary condition b for the first function, and then we subtract it by plugging in the boundary condition a from our second function. And so to illustrate this, we'll just look at a simple example problem where we have an integral that's evaluated from -3 to 1. And so the first step is we want to integrate this integral. And so we can do that by using standard integration techniques related to the power. So we'll just add 1 to the power, divide it by the new power for all three terms. And then with a little bit of simplification, we have our solution for our integral. The next step is we want to evaluate this solution at our boundary conditions. And like I said earlier, our boundary conditions are from -3 to 1. And so we'll always evaluate the boundary condition at the top, which is 1. So you can see here, all we're doing is plugging in this 1 for our x term into all three terms. And then we can subtract it by evaluating the second boundary condition and plugging in -3 into our x position for all three terms. And then we can go ahead and just simplify it by adding or subtracting all of the different terms. And so what we're left with is a little bit of some fractions, and then we'll subtract it by some more fractions. And then after a little bit more simplification, we'll get 3/2 for our first or our left-hand side, and then we'll get -165/2 for our right-hand side. And then the big key here when evaluating negative boundary conditions is just watch your signs. These two negative signs will transition it into an addition sign. And so our solution will be 168/2 or 84.